So we're gonna start the solution topic, okay? And I'm gonna skip the bullshit and get straight to the point. So, a few things about the solutions. They are homogeneous mixtures. Oh crap! Hang on a second. Let me plug it in. Okay, here we go. Chapter 9. Solutions are homogeneous mixtures. This is frustrating, but okay. Right, let it just... So they are, as we said, homogeneous mixtures, okay? There is some sort of interaction between the solute and the solvent, and these terms apply. The solvent is in much larger amount. There are some exceptions, and I will illustrate them for you. And the solute is in the smaller amount, okay? I want to highlight that when we use the word amount, it does not essentially mean mass. It means moles. Am I clear? Okay. So, we are going to talk for the most part about the aqueous solutions, in which the role of solvent is played by water. But the solutes can be very different. Solvents can be solids, like salt, liquids, like let's say ethanol, or gases like carbon dioxide. Okay? When solutes and solvents are mixed, the resulting mixture has the same physical state. In other words, it is homogeneous. When you look at the salt solution, it's all liquid. When you look at carbonated water, it's liquid. Okay? The most important thing that distinguishes a true solution from anything else is that solute and the solvent cannot be separated by filtration. Specifically by filtration. If you take a solution of table salt, run it through a filter, it's going to come out the same. You need to evaporate. Okay? So, you all know that solutes can give solutions a color. You've already learned that the process of dissolution may result in the release or absorption of energy, but at the end of the day, you're going to get this homogeneous mixture. The copper sulfate is a blue-colored salt, and if you dissolve it in water, dissolution means that there are particles of probably, well, particles of, let's say it's going to be sulfate, and particles of copper in that solution. Individual ions float around. Make sense? Now, here are some solution types. So air is the solution. Do you remember which gas is present? Which gas constitutes the majority of air? Nitrogen. It is a solvent. Everything else is a solute. Air is the solution of oxygen in nitrogen. Okay? Gas and liquid. We mentioned ammonia solution, carbonated water, liquid in liquid. I gave an example of, say, vodka is liquid in liquid, ethanol in water, vinegar, liquid in liquid. A lot of household cleaners are liquid in liquid. Solid in liquid, yeah. Now, little note, you see this term tincture? So tincture are alcohol-based solutions. Those of you who end up in whatever health profession you are focusing on, there are tinctures. They're not common, but there are medicinals that are tinctures. Solid and solid, any kind of alloy, okay, brass, steel. You didn't know that steel is a solution? And actually, well, I can give you an idea. Can you imagine, think about something that's made out of steel. It is pretty strong mechanically, right? And it also has a certain degree flexibility, I should say. Like, it's not, what's the word? When something can be easily broken. Fragile. No, fragile. Like, it's not super fragile, okay? But if you have steel and you start increasing the proportion of carbon, which is a solute, in iron, you go from steel to cast iron. And if you drop a cast iron something, it can actually break. Yes, because greater proportion of carbon makes it even harder mechanically, but also removes that flexibility. Okay? We're going to focus on water-based solutions. What you need to remember, well, obviously, it is the most common solvent in nature. And water is a polar solvent. Making sense? Life, as we know it, is entirely water-based. The polar properties of water explain why, explain a lot of biological processes, how they occur, from transport to signaling to other stuff. Okay? So, why compounds get dissolved? The molecules or ions within the solute interact with each other. Do you agree with me? Okay? If the interaction between the solute and the solvent is energetically preferable, okay, then there's going to be a dissolution. Here's what I mean. So you have solute interaction, and you have solvent interaction. Make sense? In order to make a solution, you need to disrupt this interaction and this. Clear? More than one solute can be, but yeah, one solvent, which is in much larger amount, and everything else are solutes. Clear? Awesome. So you need to break up those interactions. When you break up a bond, do you need to invest energy? Yes. So you need to give some energy investment, right? But then, if you analyze what you're going to get from interaction between the solute and the solvent, if formation of this, it's not a bond, but relationship, results in overall energy benefit, reduces the overall energy of the system, you're going to have the solution. So these examples here, for instance, show you that not everything will mix. Does that make sense? The easiest, okay, so you can have something insoluble. I'm trying to think what you can get in the house. Old stuff. Can't think from top of my head. Well, okay. calcium sulfate, calcium carbonate, even better, chalk. Not easily soluble. Does that make sense? Calcium sulfate, which is, what are they? Plaster, the casts. Not easily soluble. You can mix it with water, but solution, not so much. Does that make sense? Water and oil, not going to form a solution. This is one of the most important things. So, substances with same polarity, polar will dissolve polar, nonpolar will dissolve nonpolar. Am I making sense? Good. So, for instance, if you will try, you can try it at home if you want to. If you will try to dissolve sodium chloride, which is ionic compound and therefore polar, in water, which is also polar, it's going to work. Everybody agrees? Good? If you will try to dissolve stearin, substance that is used to make candles, which is nonpolar, in, I don't know, gasoline or oil, it's going to work. It's going to take some time, maybe heating, but it will produce a true actual solution, right? But if you will try to dissolve salt in oil, not going to happen. Okay? I'm going to make a sort of a popular culture reference. Did anyone see the show called The Queen of the South? Okay, great show. At some point, they smuggle cocaine into the United States by dissolving it in tequila. Okay? Tequila, essentially, is water plus ethanol. Okay? Both of them are polar, but ethanol is organic compound. Cocaine is a fairly polar molecule, not too much, but it has a large organic chunk. So water and ethanol have this unique combination of polar and non-polar dissolving properties. It's going to work. Like, that is, you can dissolve cocaine in tequila. Not that I'm endorsing this. Okay? But it, from the chemical standpoint, it makes sense. Yes. So again? What do you mean? Oh, no. They bought tequila, had cocaine, and dissolved cocaine in tequila, and then labeled it as just, we importing tequila in the United States. Oh, evaporation. You just pour it in a Erlenmeyer flask, heat it up. Just make sure, you have to make sure. Say again? No. Cocaine's pretty stable. It's similar to various catecholamines, and it's an amine, it's organic amine. It can withstand, I'm not saying get a boil it at 212, but you can moderately heat it up and just take your time with it. Okay? Say again? Yes, but it is a relevant thing.
Or you just drink it as is. Just drink cocaine.
No. From the physiological standpoint, it's going to completely ruin everything, because cocaine is a very strong inhibitor of the uptake of serotonin. So that was a lovely rant. Banter, I would say, rather. So we going to talk about the process of dissolution of ionic compounds versus molecular compounds. So when you have ionic compounds, like sodium chloride, when and if they get dissolved, they dissociate, forming ions. Okay? Does that make sense? So what you essentially have are individual ions of sodium and chloride floating around in water. Now, if you remember anything about water, you remember that hydrogens have partial positive charge. Make sense? Chloride has a negative charge. So chloride will interact with molecules of water, okay? And it's called salvation. So chloride is salvated, but we can say hydration. Okay? Same is true for sodium, because oxygens, as you may remember here, they have a partially positive, negative charge. So positively charged sodium ions will interact with oxygens of water and forming hydrogen bonds, essentially. Am I making sense? So, yes, when and if ionic compound gets dissolved, it dissociates, period. Dissociated ions, separate ions, they interact with water, becoming salvated or hydrated, it's same meaning. The negatively charged ions, like chloride, will interact with partially positive hydrogens of water molecules, because remember, water has partially negative charge on oxygen and partially positive charges on hydrogens because of the difference in electronegativity. Okay? And positively charged ions from here will interact with partially negative oxygen. Go ahead. Question? No? Okay. No, that's fine. Now, polar molecular compounds will also successfully dissolve in water. So, for instance, methyl alcohol or methanol, okay? The bond here is the polar. Oxygen has a partially negative charge, and carbon has a partially positive charge. So it will form those bonds between, say, oxygen and hydrogen. Am I making sense? So this is why, we have solutions like basically any strong alcohol, like, okay, clear strong alcohol, vodka. Cocaine? No. That's tequila. So vodka. It would be wild if somebody else would listen to this. Like out of nowhere, there's cocaine in the middle of conversation. So vodka is the solution of ethanol in water. That's it. Nothing else. That make sense? So this, polar solutes, polar solvents. Okay? Now, polar in this instance means molecular, so another example of polar solute being dissolved in polar solvent, sugar in water. Sugar is polar. It's molecular, but it's polar. Okay? You cannot dissolve sugar in oil. Right? So, what is the solute in example A? Sugar, because there's less of it. What is the solute in example B? Methanol, yes. What is the solute in example C? And example D?